So, take a look at number 1. Molybdenum, 96. If we write this out, what does it end on? 4D4. So, noble gas configuration, nearest preceding noble gas is? Krypton. 5s2. Come on, pen, work. 4d4. Now, look at the orbital diagram. We'll start it with the 5s. 5s, 4d, 1, 2, 3, 4, 5. Spin up, spin down, spin up, spin up, spin up, spin up. So, take a look at 4d4. How close are we to being halfway filled? We're 1 electron away. MO is one of your exceptions you have got to know. Okay? So, exceptions to electron configuration. Molybdenum is one of them. We're going to take an electron from the 5s and place it in the 4d. So, your last electron filled in is that one. Your 4d is now halfway filled up. Your 5s is halfway filled up. This is a more stable electron configuration for molybdenum. Now, what are your 4 quantum numbers here? Energy level is 5. Your sub-level is D, so that's number 2. Your orbitals, 0, plus 1, plus 2, minus 1, minus 2. You filled into which orbital? Plus 2. And is it spin up or spin down? So plus 1/2. My bad. You're right. It is not energy level 5. It is indeed energy level 4. Oopsie. Good catch, though. So, what besides molybdenum, what are your other exceptions you need to know? Right above molybdenum is what? Chromium. And we have copper. And we have silver. And technically, there's one more right below silver, and gold. So those are 5 that are all exceptions to your electron configurations. They'll borrow one from the S and put it into the D to either be halfway filled, like chromium and molybdenum, or fully filled to be like copper, silver, or AU as examples of that.
So do we need to know 4 or 5?
I don't believe I asked you about gold, so technically 4, but I mean technically gold will take one from the 6S and place it in the 5D. So it's the same concept. Okay, number 2. This is a question that we haven't really addressed yet, but you guys actually are pretty familiar with it already. 6p6. What ends on 6p6? Radon?
Radon's what I meant. You know what I meant.
So radon is an example of something that's neutral that ends on 6p6. What other species, ions, end on 6p6? So what gains and loses electrons to be like radon?
1A or augmentation.
So what does francium have to do to be like radon? You have to be plus 1. You have to lose an electron. 87 electrons, lose 1 electron to have 86, like radon. Perfect. What else can follow that? Radium, which is going to be plus 2. Oxidation state plus 2. Okay, what about on the opposite side? What about AT? What do I have to do for AT? I have to gain an electron, so that's going to be minus 1. What about PO? Minus 2. You seen the pattern here?
Yeah.
There's an endless amount of examples you can provide, but all you have to do is add and subtract electrons to get to specific electron configurations. Okay? Take a look at number 3. Sodium. How many valence electrons? What group's it in? It's in group 1, so it has 1. What about magnesium? Group 2, so it has 2. Aluminum? Group 13, so it has 3. Phosphorus? 15, so you have 5. Iodine? Group 17, so you have 7 valence electrons. So you should know that pattern going across the periodic table. You'll get what? The pattern? So let's jump over. If we look at our periodic table, so here, group 1 has one valence electron. Let me jump over to writing everything if I can. So I have 1 valence electron for group 1, 2 valence electrons for group 2. Skip over the transition metals. 3 for 13, 4 for 14, 5 for 15, 6, 7, and the noble gases have 8 valence electrons. That's your pattern on the periodic table. Okay. So, jumping down here, what is your definition for atomic radius? So you have 2 definitions I'll actually accept here. One is not really a great definition, but you know the definition of radius. It is from the center point of the nucleus to outermost electron. But what's the problem with this definition? We don't observe that. So if we don't observe that, the more formal definition is half the distance between 2 nuclei in a bond. So that's your more formal definition for atomic radius. What's your definition of electronegativity? Yeah, so the attraction between the nucleus and valence electrons, more specifically, it's the pulling power the nucleus has on electrons in a bond. Okay, we'll get into more electronegativity when we get into our unit on bonding. Last one. First ionization energy. Energy needed to pull off your first electron. And remember, this is in a gaseous state. So if that's your definition for first ionization energy, what do you think second ionization energy would be? Yeah. If I already have my first electron pulled off, how much energy does it take to pull off a second electron? All right, take a look at these examples, 6 and 7. Explain why oxygen has a larger first ionization energy than selenium. Are we looking at the same group or the same period? They're in the same group. So we are identifying which one has more or less shielding. So comparing oxygen to selenium, which one has, or oxygen in particular, does have more or less shielding than selenium? Oxygen is higher up on the periodic table, so it has less shielding. So it has a better hold on its electrons, and it has a higher first ionization energy. What about oxygen in comparison to boron? Oxygen in comparison to boron. So, oxygen and boron are in the same period. What does that mean? What does oxygen have more of? Higher E and C, which basically means more protons. And if it has more protons, that means it has a higher attraction to the nucleus, or from the nucleus to the valence electrons. So, if it has more attraction, it has a higher first ionization energy for oxygen. Why does oxygen have the higher first ionization energy? So again, all of these answers are right here, electron review answers. If you need more help with this or more practice beyond the study guide, there's another review series of questions. Questions about anything we've gone over so far? So take a look at this table. What do you need to know to answer or to fill out this table? Atomic number is equal to what? Protons. Mass number is equal to protons plus neutrons. And charge is equal to protons minus electrons. So, if we look, atomic number is 8. That means our protons is 8. The number of electrons corresponds with the charge. So 8 minus what equals negative 2? 10. 8 minus 10 is negative 2. Number of protons in atomic number tells us that our symbol is oxygen. And protons, 8, neutrons, 10, give you a mass number of 18. 8 plus 10 is 18. Next one. Protons is 10. Atomic number is 10. This is neon. I have 10 electrons, 10 protons, so my charge is 0. I have a mass of 22. 22 minus 10 gives me 12 neutrons. 12 protons. Atomic number is 12. What symbol has 12 protons? Magnesium. Mass number is 12 plus 14, so 26. And the charge, 12 electrons, 12 protons, 0 for charge. Bohr models. I'm not going to draw these for you, but just remember, number of protons, number of neutrons in your nucleus, write it out. 2, 8, 8, 2 is the largest amount of electrons I'll ask you to draw a Bohr model for. Beyond that, we'll just be dealing with the quantum mechanical model in electron configuration. All right, number 10. Most common ion of oxygen. Is oxygen going to gain or lose electrons? It wants to gain to be like what noble gas? Neon. So it has 8 electrons. How many does it have to gain? 2. So O, negative 2 is the most common ion. How many protons and electrons are in the oxide ion? Well, if I have 8 protons, how many electrons must I have? 10. If I have a negative 2 charge, 8 minus what equals negative 2? We actually just did this problem up in this table, right? So, draw the Lewis dot structure for the oxide ion. Well, I know oxygen, the elemental oxygen, has 6 because it's in group 16. So 2 paired, 2 unpaired. So oxide, you would gain those 2 electrons, should have 4 paired electrons. So there's oxide, there's oxygen. How many paired electrons exist for oxide? 1, 2, 3, 4. How many unpaired electrons are there for elemental oxygen? 2. What noble gas does this resemble? And why does it resemble neon? Same electron configuration. So yes, same number of electrons. So again, every element wants to be like a noble gas. How do they become like a noble gas? They have the same electron configurations. All right, moving on. Metals versus nonmetals. Okay, if we look at electronegativity, let's jump over to our periodic table. If we look at electronegativity, so if we jump onto ptable.com, go to properties, and you can click on electronegativity, and now it's scaled it for you in terms of color. So your most electronegative element is fluorine. You can see this with this deep orange. And then the yellow on the opposite side of the periodic table, francium, is your least electronegative element. So nonmetals are up in the upper right. Do they have higher or lower electronegativity than metals? Much higher. And then your metals have lower electronegativity. So there's a good diagram for you guys to look at if you wanted to compare metals to nonmetals for electronegativity. What? ptable.com. So take a look at ptable.com. Click on properties. And then click on electronegativity to get that scaling. All right, but 12, 13, and 14 closely resemble what type of questions you'll be asked to do on the test. So decide which one has a larger radius, oxygen or oxide. Why does oxide have a larger radius? No, not more shielding. Has the same amount of protons, but we added 2 electrons in. So, because we added 2 electrons in, it gets slightly bigger. Calcium versus Ca plus 2. Which one's larger? Calcium. Now, what's your justification? Well, I have the same amount of protons. I lost 2 electrons. Now your justification of more shielding actually makes sense. Because you had 20 protons in the nucleus. 2, 8, 8, 2. In order to become this is Ca. In order to become Ca plus 2, you have to get rid of these electrons right here. So yeah, technically now you have less shielding for Ca plus 2, so calcium is your larger radius. So these two are dealing with ionic radii. The next two are dealing with atomic radii. These are the ones you're used to. Compare sodium to potassium. Same group or period? It's in the same group. So which one has more shielding? Potassium. So because it has more shielding, it has a larger radius. What about phosphorus and sulfur? Same period or group? Same period. Which one has less protons? Phosphorus, because it has less ENC, less protons, it has a larger radius. Sulfur will pull that valence shell in closer than phosphorus will because it has more ENC. Which has the larger first ionization energy, carbon or nitrogen? Nitrogen. Why? Same period, more ENC. Larger first ionization energy between fluorine and bromine. Fluorine, because fluorine has less shielding. Magnesium and strontium. Same group. So, which one has less shielding? Magnesium has less shielding. All of these so far, and really all of them to come, all deal with the attraction of the nucleus to the outermost electron. So the more attraction you have, changes these properties. The less attraction you have, changes these properties. The attraction all deals with how many protons or how much shielding. So again, it's all about this attraction between the nucleus and valence shell. Alright, I changed it up on you. Smaller electronegativity. So, in this case, rubidium and francium. Why francium? Has less shielding, or has more shielding. So, it has less attraction and therefore smaller electronegativity. What about rubidium and strontium? Same period. So we're talking about the one with less ENC, rubidium. Less ENC. All right, what about magnesium and chlorine? Magnesium, again, same period, so less ENC. Fluorine and iodine. Why iodine? More shielding. Look how simplistic your justification can be. These are the types of responses I expect on your test. I don't want very long paragraphs. Just give me the short, sweet justification after you state which one has higher or lower of whatever the trend we're talking about. All right, let's quickly finish this. Name a group 1. Group 1 is called the alkali metals. Group 2, what is that called? Alkaline earth metals. What's group 17? Halogens. What's group 18? Noble gases. These are all from the activity we did on ptable.com where you guys were looking up all the information about the periodic table. We did that early on. All right, we've already defined A, B, and C for atomic radii, first ionization energy, and electronegativity, so I'm going to skip those. But again, this very much resembles what you're going to see and have to do on this test coming up. So, make sure you check your answers. Make sure you do all of your homework prior to the test. Any last questions?